Welcome to C# Essentials. This course is a series of videos intended to help beginner developers and beginner developers in the C# programming language to get started and build their confidence. As we start to write more and more code, we find that it's quite common that we encounter situations where we have an algorithm or a formula or something that we need to use over and over again that becomes repetitive. And what we try and do to make our code more readable and understandable and maintainable, easier to maintain over time, is to avoid repeated code. So if we have one or more lines of code that group together do something useful, then we tend to group them into what's known as a function and give that function a name so that we can reuse that code over and over again. I know this sounds a little bit strange at first, but once you've seen it in practice, it becomes quite easy to understand. Consequently, this episode is mostly about examples. But when we talk about encapsulation, we're talking about creating something we call a function. You could call it a method in some circumstances in C#. We'll get to that later. It's not important. The naming right now is not important. What we call it is not important. In some programming environments or spreadsheets even, we talk about subroutines or macros. It's a very, very similar concept. When we create a function, very importantly, we give our function a name. Every function in a namespace needs a unique name. What a namespace means exactly we'll get to later. Don't worry about it right now. Suffice it to say, in your C# application that you're creating, every function right now needs a unique name. A function's name typically would consist of letters and possibly numbers, ideally mostly letters. Typically camel case, so uppercase, lowercase combinations of letters, normally starting with an uppercase letter. I'll show you that by example. What's important is a function needs a unique name within its environment. A function can take input. We can give functions variables, if you want, the values in variables that they can work with to do something in order to produce a result. And typically we treat those input values within the function, we treat them as read-only. We don't change those values. We just use the values that we are given. This does change potentially in the future, and it is possible that sometimes functions can change the value of their inputs, but we're not going to do that right now. The function can also produce a result which it can return to whatever executed the function, what we call the caller of the function. And we talk about return values. A function can have a return value. In fact, in recent years, a C# function can have multiple return values, which we call a tuple, a T-U-P-L-E. We're not going to look at tuples right now. We'll get to them later. A function's interface, or its full definition, excluding the code that makes up the function, is called its interface, and it also has an access modifier, which also we will get to later. It's really not relevant right now. What's relevant right now is the concept of a function with a name and a body, and that body consists of code that does something that we can reuse over and over again. Before we continue, please remember that the best way to learn how to program is to get your hands dirty, to try hands-on examples. And this is why most of the episodes in this series are largely recordings of hands-on demonstrations in VS Code with narrative and supported by occasional more theoretical slide content. If you have missed previous episodes and you'd like to catch up, there is a link in the comments to the playlist for this series, but it's also shown to you on the screen right now. So you can go there and go back to previous episodes of this series. Please like and subscribe. This really helps us to continue to produce this content and to help others and others who need to learn more about C# and programming in general. Please also share. Anybody you know that could benefit from this content, please let them know that it exists. And also, very importantly, please comment. Please let us know if you think we could do better, if you would like to suggest that we can improve certain aspects of our content. Please let us know. We really treasure your input. Thank you. So let's imagine a really simple example that hopefully will illustrate the reason why we use functions so much when we are writing code in any programming language, including C#. Here I have a list of double values that I have given the name London temps F. What I mean by that is London temperatures Fahrenheit, for example. And this is a list of doubles, and I've assigned to it 12 values, 102, 93, 95, whatever. In previous exercises or examples, we did stuff like London temps F dot add, and then we put more values in, and that's how we would have added the 102, 93, 95. It turns out that the syntax that you're looking at now is a convenient syntax for an initialization for a new list, and it's just simpler. We saw it for an array of doubles in the previous episode. Now we're seeing that it can be done for a list as well. So if we wanted to calculate the average for our temperatures in London, we could do something like double London average. We can make it 0. And then we saw this in the previous episode that we could do things like for each double temperature in London temps Fahrenheit. And then we could say London average equals to London average plus the temp. And we will see that all of this can become much more succinct code as we go along, but don't worry about it for the moment. And then finally we could say that the London average is equal to the London average divided by the number of items in the list. So this could be London temps Fahrenheit dot count. And this we learned in the previous episode in the series. And we learned that we could also, we've seen this all before, so we'll have an interpolated string and we'll say average temperature is something like, let's put it in London average, and then we can put a capital F after it. And let's just check that this does something useful. So we'll go to the terminal. As we know, we can go to the menu and click terminal, new terminal, or we can hit Control Shift and then the back quote key. Doesn't matter. .NET Run, and hopefully we're going to see an average value for the London temperature, which probably will be 90. Well, there you go, 94.08. That's great. So that works. But now it's inevitable that because this is useful, somebody is going to come along and say, well, hang on a minute. What about if we do this for Paris as well? So what we could do, and this is the bad idea, so this is what we don't want to do, but what we could do is basically just duplicate our code. We could repeat ourselves. So let's give ourselves some more space. And let's take all of this code here and copy it and paste it. So just copy and paste. Now you can see at the moment we've got some errors because we've duplicated the names of variables, which we're not allowed to do, as you guys would already know. So we can go and rename, and now we obviously have to be very careful that everywhere that previously it said London, we now change it to be Paris. And a little bit further down here, I suppose I could have done a find and replace, but it doesn't matter. Life is fun. What we want to make sure of is that we understand our code, and so I'm avoiding using shorthand code at the moment. I really want you guys to understand this code intimately yourselves and to have tried it yourselves. Now, believe it or not, from my accent, I am in fact a Londoner. So it turns out that Paris is typically warmer than London. It's closer to the equator. So let's up some of these values so that we get a slightly higher value as the average. And what we're going to do now is we're going to, let's say, we're going to have London average temperature, and then we're going to have Paris average temperature. Save that and let's run it again. Okay, and now we have London average temperature of 94 point something and Paris average of 98. And that's wonderful. That the point is we're getting a result that, let's try and get this into a slightly smaller format. That's maybe too small. The problem is we've duplicated the code, and duplicating code, repeating code is the ultimate sin in coding. We don't want to do this because if, for example, we made a mistake in the calculation of the average, we now have repeated the mistake twice. It's possible in the future somebody else could go and try and fix that by changing the mistake, but only change it in one place, and then it still resides in the other place. This is why we don't want duplicate code. The way we fix this is really, really simple. We create a new function. So it turns out that all of our code is between these curly braces, and we've known this already. We knew this from episode 2 of this series, between the curly braces. And those curly braces encapsulate all of the code that lives in the function main. So we've been working in a function within the realm of a function all the time. And we're going to create another one. So here we're going to go down here and we're going to say static, and we're going to say that double, and you'll understand why double is here in a bit. And we're going to say get average temperatures, temps, let's call it that because we don't want to watch me typing forever. And we're going to say that this get av temps, which is the name of our function, is going to expect the parameter of a list of double values. Let's call it temps. And what we've said so far is static, which is the access modifier that we referred to in our slides earlier. All of our functions for the next couple of episodes are going to be static, but if you look at our previous function, it's also static. Static void main. Void means no return value. Double means this function, get av temps, is going to return a value, and that return value is going to be a double. It could be an int, it could be a bool, it could be a string, whatever. It's going to be a double. And what I'm going to do here is I'm going to reuse my code from here. I'm just going to copy from there. I'm going to paste it into here. And I'm just going to rename this. Now, you'll find that in VS Code, in Visual Studio Code, you can right-click on a variable name like this and say rename symbol. And I'm going to do this. And I'm going to rename this as average. And you'll see it's renamed it throughout the scope of this function. And I'm going to rename this is just temps. We'll just make this temps like that. And that didn't work, doesn't matter. Okay, so our algorithm is still the same. We take our list, we iterate through each item in it, we add each item to our average, and then finally we divide the average by the number of items in the list, and that gives us the actual average. You'll see that we still have got this squiggly red line that says it's an error, and the problem is what it's telling us is not all paths return a value. What that means is we've defined this new function, we've declared this function, get av temps, and we've said it returns a double value, which is obviously our average in this case. but we haven't returned it. So what we're going to do is we're going to go down to the bottom here and say return average. And as soon as we do that, our red squiggly line goes away. We have no more errors. And what that means is that we now have a function that is going to accept as a parameter a list of double values. It's going to iterate through each of those values, add them all together, and then divide by the number of values we encountered and return an average. Now, I'm not suggesting that this is the cleverest way of doing this, and in fact later on I will show you other ways that this could be done with a list. It's not the point. The point right now is previously we had repeating code, and we want to avoid that repeating code by bringing that repeating code into a little group, a little black box all on its own, give that little black box a name, and then reuse that black box elsewhere in our calling code. So here's our calling code. And so here we have London average, and what we can do is, instead of doing all of this, we're going to reuse our function. So we're going to say get average temps, and we're going to say London temps F. Okay, and then we're going to do the same thing here. We're going to get rid of all of this body, which is the duplicated code that we had before, and we're going to do get average temps Paris temps F. Okay. Now, a really important lesson for you to learn as a coder is every time you refactor code, we've just done a refactoring. We often talk about refactoring code, changing the layout, changing the structure or the nature of our code, but ultimately the intention of refactoring is it should do the same thing later or better, but possibly in a slightly different structure. What we want to make sure is that we get the same answer. The same answer should be 94.08 and 98.25. So let's see if that is true. Let's go down to the terminal and run our application again and make sure that we get the same value, 94.08 and 98.25. It's perfect. What we've achieved so far is we've managed to reuse the repeating code. We don't repeat this code anymore. Our code has become cleaner. The calling code simply executes the function, provides a value for the what we call the argument value, which in this side we call the parameter, the input. We give it an input value. It does whatever it needs to do. It returns the resulting value, and we consume that value and assign it to a local variable, which we then express elsewhere in the calling code. This is a very, very common example of using a function in our C# code, and it's really important to remember the terms. This is the interface. This is the interface for our function. Our function has a name. It has an optional list of parameters. Most functions have parameters. Some don't. Don't worry about them right now. Let's focus on the simple things. So we have a function that has a name. It has a definition of one or more parameters. This could include other things. It could include a string of a name and an integer of a count, and it doesn't matter. The point is, every time this function is called, the caller will have to match, will have to provide a value, an argument value for each parameter. Right now we're seeing a red squiggly line here because C# is telling us that our request to execute get average temperatures doesn't match the interface. If I get rid of those extra definitions, the error goes away and we're back in the happy world of matching the interface definition. Let's try another simple example now that our average temperatures scenario works. We're then told by the business that they want us to provide the temperature, the average temperature for both cities in Celsius, in metric in other words, as well as Fahrenheit or imperial. And this makes perfect sense because sometimes in London, where I mostly live, people often refer to temperature in Fahrenheit, whereas certainly in Europe, in Paris, they definitely refer to temperature and metric values. So let's have a look at how we do that. The first thing that I'm going to do, and I did this in advance of recording here, is I changed my variable names to the average temperature in F and Paris temperature in F. The reason being that I now want to say I want London average in Celsius is equal to, and we learned about this in a previous episode in this course, that if we want to convert Fahrenheit to Celsius, what we do is we subtract 32 from the Fahrenheit value and then multiply by 5 over 9. 5 divided by 9. So now we can add this to our output string, so we can say that this is London average C and put a space in C. And it's quite clear that we could copy and paste this, so we could take this down to here and apply this for Paris as well. So equally for Paris, we have a Paris average centigrade Celsius. There we go. And if I run my application now, there we go. We have our Fahrenheit and Celsius values, and they look roughly correct. The problem, of course, is that we are duplicating code. Our duplicated code is here. This is the duplicated code. It contains a formula. It contains something that could change over time. In this example, it won't change over time because there is only one way forever of converting from Fahrenheit to Celsius. But if it was some kind of business calculation or something that is defined in your business, then it could change over time. So what we want to do now is we want to create a new function that does this conversion for us. What we need to do is go outside the boundaries of the body of the current function. This is our main function, remember, and the body of our function is inside these curly brackets. So I'm going to go outside of it, but still within the same namespace, which is here. And I'm going to create another function. Let's call this convert Fahrenheit to Celsius. I'm going to give it a double value of Fahrenheit. You can see at the moment it's telling me that I've got a problem because I'm not returning a value right now. Not all code paths return a value. So what I could do here is I could, for really easy to understand code, I could say Celsius equals to Fahrenheit minus 32 times 5 divided by 9. And now I could quite simply just use this instead. So I could convert Fahrenheit to Celsius. Gives us the London average, and convert Fahrenheit to Celsius for the Paris average. Gives us the Paris value. Sure, this is not as significant an example. We can see that I've still got an error here, and it's because I've forgotten in my code down here to return the result value. So here I'm going to return the Celsius result value that I've calculated. And if I run my code again, I should see a value for both results. There we go. We've got the same results as we were getting before when we were duplicating the code, 34.49, 36.8, and we've avoided duplicating the code. We are not repeating ourselves, and that's really important. So that's another really simple but important example of how we can define a function, give it an interface, a name, a return value, some parameter definitions, create the function, tell it to return the result, and then reuse that function code elsewhere in our application. Thank you for spending your valuable time with us. Please join us for future sessions and learning how to code in C#. Please remember, as much as possible, to try to experiment with the hands-on examples we are showing you in these episodes. Please like and subscribe so that other folk can get the benefit from this content. And also, please let us know if you have any recommendations about changes we can make or topics we can cover in the future. Thank you.